Hi everyone, and welcome to this introduction to my Dead Earth game development channel here at the Game Institute. Now in this video I'm just going to introduce myself, tell you a little bit about the game as well as how this tutorial series is going to work, and also going to have a bit of informal chit chat, and in the next video we'll actually start constructing the game. Okay, so first of all let me tell you a little bit about who I am. I'm Gary Simmons. I am a Unity instructor here at the Game Institute, as well as the co-developer and sole programmer on the Dead Earth game. Now, I first started to learn computer game development in 1982. I was about 11 years old at the time. So since then I've programmed for many different platforms, environments, and using many different languages. And I've been developing in Unity since version 3, so many years now. Okay, so Dead Earth. It's a first-person shooter horror survival game set in a future where a company called Elan Vital Pharmaceuticals, after creating a nanobiological treatment to prolong life, is thought to be responsible for the outbreak of the Rage. Now, the game is set many years after the initial outbreak, where mankind is kind of surviving and rebuilding in small pockets of civilization, but where most of the Earth is still left abandoned to those infected by the Rage, euphemistically referred to as the Raggies. Now, the first mission will see us venture out into the Raglands after losing contact with a team of scientists from the Center of Rage Research. These guys were stationed at an observation post deep within hostile territory in Quarantine Zone 351, and you've guessed it, we've been sent to investigate, just like Brad Pitt. And that's all I'm saying for now, but things would not turn out exactly as they seem. Now, the game is still very much in development, okay, so I'm going to be releasing videos of my earlier progress as I continue to work on the game. So in some ways, this is going to be like a developer's diary as well. Now, the aim of this video series was to try and make a first-person shooter game that might pass for commercial quality or close to it, with virtually no people and virtually no money. I'm sure that's a situation most of us find ourselves in. In fact, for the most part, Dead Earth has been created by just two people, myself as the programmer, and in my videos I will discuss and distribute all the scripts that I write for this game so that you can use them in your own projects. And also my brother Darren Simmons. Darren has his own set of videos for Dead Earth, where he will take you step by step through the level creation process that he's gone through, as well as show you the assets that we purchased from Unity's asset store to help us bring this project to fruition. So all of the assets that we use in Dead Earth are actually freely available for you to purchase too, if you wanted to follow along with us exactly. But hey, you probably got your own ideas about the type of game you want to create, and you've probably got your own ideas about the art that you want to use for it. But either way, the choice is yours. But be sure to subscribe to Darren's Dead Earth videos as well, so you get a complete picture of how the game Dead Earth was developed. Now just remember, if you are a lone developer or a small development shop, the Unity Asset Store is quite literally your very best friend. For between $40 to $60 a pop on average, you can purchase commercial quality animations, character models, in fact, entire themed asset packs that can be used to construct entire levels. Now, it's historically cost software companies tens of thousands, perhaps even hundreds of thousands, to have this level of quality artwork created for them bespoke. But with the asset store, even if you're a lone programmer with no artistic skill, you can probably purchase top quality artwork for your entire game for probably less than a few $1,000s all in. Now, I know that might sound a lot of money to some of you, but trust me, it's a minuscule amount, contextually speaking, to bring a game to fruition with high quality visuals. So let's talk about some of the things that you're going to learn from me in my Dead Earth videos. Now, this list is by no means an exhaustive list, as I haven't finished the game yet. Therefore, there's probably some stuff that I'm yet to implement, and probably some stuff I don't even know I've got to implement yet, that will obviously be added to this list. The non-player characters in our game world are going to need to be able to navigate the game world in a seemingly intelligent way. Now, if we wish a character to pursue the player, for example, we can't simply move the character as the crow flies directly towards the player in a straight line, or it's going to be passing through walls and mountains and parked cars and cupboards and any other solid objects that are in our level. Now we're going to be exploring and using Unity's navigation and pathfinding subsystems to do this. We're going to learn how to build a graph that describes the traversable areas of our world and their connections, called a nav mesh. We're also going to look at Unity's pathfinding component called NavAgent that can be used to plot efficient paths throughout the game world using the nav mesh. And we're also going to see how we can use Unity's navigation obstacle component to allow our dynamic characters to avoid other dynamic entities as they follow their paths. I'm also going to see how we can update the pre-compiled nav graph at runtime to cater for portal situations, things such as doors opening and closing that might enable or disable routes that the AI can take. Now, pathfinding and environment traversal is just one part that's needed for our artificial intelligence. We're also going to need to write code to control the decision-making process of the character. It's not just about knowing how to navigate to a destination, it's about knowing why and when to navigate there. Now, the zombie AI in Dead Earth will have many properties and states, all that are invoked based on external stimuli. A zombie will obviously react to any player that enters its field of view and go into pursuit mode and relentlessly chase that player. But our zombies will also be sensitive to sound and light as well. If a zombie hears a sound, for example, it will try to investigate the source of that sound. Similarly, a zombie may be facing away from the player so that he doesn't know the player's there, but if you shine your flashlight in his direction, he will become aware of the increased illumination happening around him and try to track the source of that light. Furthermore, we will also throw in some other seemingly random behaviors as well. For example, an AI zombie in Dead Earth will have a hunger property that will drain down as he patrols. Now, a very hungry zombie will see a dead body laid on the ground and will deviate from its patrol route and go and have a feast on it. Unity has a very powerful animation subsystem called Mechanim, which our game will rely heavily on for a variety of its functionality. We will see how to import characters and animations and how to retarget animations from one character to another. That is, we will see how animations originally created for one specific humanoid bone hierarchy can be used on all of our other humanoid characters, even though their bone hierarchies share different names and configurations. Now, this is a very powerful and welcome feature of Mechanim, and it's especially important for us because we're going to be using many characters created by many different authors, and as such, our characters will not all have identical humanoid rigs with which to animate. So animation retargeting will allow us to use any humanoid animation that we find and apply it to any of our humanoid character rigs. We're also going to see how to build complex multi-layered animation state machines to control the blending of our character between animations. The state machine will handle all of the timing and transitions from one state to the other, such as transitioning from a walking state, for example, into another state such as attacking. Now, the communication of data between our scripts and the animation state machine will be two-way so that our animations can also drive and trigger events in our own mono behaviors. We're also going to see how to use avatar masks to restrict certain animations or layers in our state machine to just specific body parts of a character, and we'll see how layers can be blended with other layers using layer weights. We're also going to be making use of animation curves, animation events, and Unity 5's new animation state behaviors, and these are going to allow us to drive events in our game directly from our animations. For example, we shouldn't just assume the weapon can be fired when the user presses the mouse button, for example. The button press should simply express this intention to the animation state machine, which may well take some time, for example, when bringing up a weapon, to actually cause the fire animation to play. The animation curves and the animation state behaviors in our animation state machines will be used to tell our code exactly the point in time in the animation's timeline that shot should occur. We are also going to create a first-person controller with a multi-weapon capable first-person arms rig. Now this is not quite as simple as it sounds and will require that we construct a complex animation state machine for our arms that can also dictate changes at runtime at very specific times to objects in our scene hierarchy. For example, an animation to reload a pistol will also need to communicate with the scene hierarchy to assure that the pistol clip game object is enabled and disabled at the correct time throughout the animation. Now, the inventory system in Dead Earth will be written using Unity's newest retained mode UI. We will learn how to pick up and drop objects, we will see how to add them to our backpack and to consume and manage them. We'll also see how to manage our weapon mounts and the changing between those various weapons, as well as other cool kind of related stuff along the way, such as the implementation of a PDA playback device so that we can store and play back from our inventory various audio logs with captions that we find throughout our game levels, and these are used to further the storyline.
This is Dr. Julia Pearson for the Centre of Rage Research. I fear this will be my final log entry.
We're also going to learn how to make our environments interactive so that we can open doors and drawers, so that we can search cupboards, activate switches, and just basically activate various sequences that enhance the gameplay. Now, Dead Earth doesn't require a complex mission or quest system, much like an RPG would, but we will still implement a very flexible and simple means of structuring the order of tasks the player has to complete. Now, let me give you an example. In the first level, one of the things that we have to do is we have to download the doctor's research notes off of a computer on the second floor. But the building has no power, so the first thing we have to do is go down into the basement and activate the power. But in order to activate the power, we need to type an access code into a keypad that we don't have. So you probably see where this is going. At some point we find an audio log that contains the access code.
It can be done from the keypad in the power control room in the hospital basement. The access code is 23021971.
Then, because we've listened to that audio log when we return to the power control room, we can now, activate the keypad and the lights and the power to the hospital come on. And you'll see how we can use these type of events to do cool things like, when the power is turned on, more zombies will be attracted into the building, because the building now has a much bigger visible footprint in the city. And when we go to the second floor of the hospital, the computer system now has power, which means we can use it to download the doctor's research notes. And while downloading the notes, we find the access code to the elevator down into the sewer system, and you get the idea. All of these things have to happen in sequence, and the system that we implement will cater for that. We're also going to see how to optimize our game world as best as we can, using both Unity's occlusion culling system, but also using various LOD and shadow control systems that we're going to implement ourselves. Now, this is vitally important for us because as developers that are importing assets from various different authors in the asset store, we don't always get the most optimized models or texture sets that we desire. Now, if I was working in a large game development house, I would instruct my team of animators to atlas all the textures and to limit all of the objects in the level to a very specific number of materials so that I get the minimum number of draw calls and a very efficient level when it comes to rendering. But we just don't have that luxury. So we're going to have to make as many savings as we can elsewhere. Okay then, so that's it for now. In the next video, we're going to start actually building stuff, okay? So I'll see you then. Bye-bye for now.